Okay, let's look at some more examples for this. All right, this is video 2 for what we're doing here, and we're going to look at how do we match up each of these with its proper graph. So I think the way I would do this is, rather than kind of guess and say, well, I think this one, I think the best thing to do is just to take each situation and then figure out kind of what the solution is, and then think about, if we were to graph it, which one of these looks like it. So for the first one, right, you got your first case, which is going to be the positive case, and then your second case is going to be, here, I'll say case, right, case 1 and case 2. Your second case is going to be the negative case, so negative x is greater than 2. All right, this one's already in good shape and ready to go, but this one you would multiply both sides by -1, and when you do that, you would get x, and then now it becomes less than -2. So we have an inequality. We're going to have a solution, a graph of solution where x is greater than 2, but then x is also anything that's less than -2. So this would be a case of an or statement. So this is a union. So let's find that one. So it looks like that should be letter B, because if you look at letter B, you've got your greater than 2 right here. So that this would be x is greater than 2 right here, and then this side over here would be x is less than -2. And so we're happy with that. We'll go with that. Now for number 2, all right, my first case, all right, case 1, I'll use a lowercase I for this, is going to be just where you drop the absolute value signs and just solve it how it is, all right? So add 2. So you got x less than or equal to 5. And then your second case, which is your negative case, is going to be where you make it negative, but you got to put it in parentheses, right, to show it. Sometimes this pad I work on just does some weird things. All right, so let's distribute that negative. We got negative x, we got plus 2, it's less than or equal to 3. Subtract 2 from both sides, and you should get negative x is less than or equal to 1. Now, let's multiply both sides by -1 so that we can get rid of the negative sign in front of the variable. When you do that, the sign flips, and then you should get -1 over here. So you have x is greater than or equal to -1, and x is less than or equal to 5. So this is going to be an intersection, right? And it looks like it should be this one right here, right? Because the x is less than or equal to 5 would be this part going this way, and then x is greater than or equal to -1, it would be this part going this way. And remember, in order for it to fulfill both things, it would have to just be the stuff where it's shared. So this would be a case of an intersection. All right, and so your solution, and you can write it like an intersection too. You could even write it like this. Okay, and away you go. Now, so that would be C right here. And so we can kind of, it's probably a bit of a foregone conclusion that number 3 is going to be A, but let's do the cases just so we can see if it is. All right, so case 1, subtract 1, and then you get x is less than 3. Okay, and then case 2 is going to be the negative case. So negative x minus 1, add 1, get 5, negative x, which means that x is greater than -5. And I didn't show the step where you multiply both by -1, but we know by now what's going to happen with that. All right, we're not confused by that anymore. So x is less than 3 and x is greater than -5. Again, here's another case where you have an intersection, and because of that, we could write our answer like this, and that is demonstrated in graphical form quite well up here. Okay, because here's your x is less than 3. It's going in this direction. And then here's your x is greater than negative 5 going in this direction. And so it's going to be all this stuff in the middle there is going to be our solution. And so there you go. We've done a little more work on this, and it's hopefully starting to kind of sink in with you a little bit and make some sense. That's the goal we're after here.